Okay, on to part D. For time greater than 18, no water is pumped into the tank, but water continues to be removed at the rate of R of t until the tank becomes empty. Let k be the time at which the tank becomes empty, and write but do not solve an equation involving an integral expression that can be used to find the value of k. Well, again, we have to think in terms of how much water is present. We need an initial value. Now we're not working with the 1200 gallons anymore. We know that at time t equals 18 there are 1310 gallons of water. So there's 1310 gallons there, and the water is being removed at a rate of R of t. So we want an integral from t equals 18 up to t equals k. That's what we're looking for. So our starting time here is 18 and not 0, and we're going up to time t equals k, and we want to find the integral of R of t. So basically all we need to do is subtract that amount from 1310, and we should end up with 0. So we're starting with, at time t equals 18, we're starting with 1310 gallons of water in the tank, and we're going to remove water at a rate of R of t, gallons per hour, and if we take the integral of that from 18 to k, we want that to be equal to 1310, or subtracted from 1310 gives you 0. We could also rewrite this as, and that's really all we need to do for this part of it. Now, you might be wondering, they don't ask you to solve for k in this particular place, but what would happen if you were asked to? How could you solve for k? Well, what we'd need to be able to do here is to graph function R of t, graph the integral of R of t. So for this we're going to go to the graphing calculator and go back to y equals, and what I want to do now is to graph the derivative function. Rather, graph the integral of the derivative function. So I go to math, option 9, fn int, I have vars, y vars, function y3, comma, variable of integration is x, and I want to start at 18, and I want to go to some point, I don't know, we'll call that x again. That allows me to have a variable ending to this. Now I need to set my window. I am going to need a lot more than 18 here, so I'm going to make it go to 100 by tens, and my y values, well, I want to find out when this function hits 1310, so I would imagine I have to go at least until, say, 1500. So I go from 0 to 1500 by 100ths, and I go to graph that. This may take some time for the graph to appear since we're covering such a wide range of values, and let's see what happens here. Well, it went up and it came down, going up again, going up again, going up again. I think that's going to break it, and from there it may just continue to go on. So I think I have what I need here, and I'm going to stop it. I can always stop it by hitting the on button. Now I want to find where that crosses 1310, so I'm going to go back and set up another function, and that would be y5 is equal to 1310. Now since I didn't need all of that space, that 100, I'm going to change my x window to go only maybe up to 50 by tens, and I'm going to regraph this now and see what happens. Hopefully we'll have time before this video runs out. So let's see. And that takes a while, but when it finishes I see the intersection there, and it happens at 28, almost 29 hours. So I hope that helps.